Welcome to this topic video on JavaScript testing. Readings. An overview in JavaScript testing in 2019 provides a good overview of software and testing tools. A quick and complete guide to Mocha testing will be our main reading, okay? And Wikipedia on behavior-driven development, a bit more explanation of some of the terminology you may encounter in testing. Okay, now references. Mocha, that's going to be the test framework that we're going to use, and Chai, all these nice food names, is going to be our assertion library. What, Professor? Don't worry, we're going to get to what all this stuff is. Don't worry. Okay, so why test? Okay, to make sure the software does what it's supposed to do. Okay, oh, good idea. Yeah, we want to make sure the software really works to see if you broke the software when you changed it. Oh, you mean like you're asked to add a new feature or to fix a bug, but then you introduce more bugs? Yeah, because testing's a lot of fun. No joke, actually. It's a different mindset, okay? It's a puzzle. It's a challenge to figure out how to test things well, okay? So, and consistently and get reasonable, what we call coverage, okay? So testing is a challenge. You cannot test exhaustively, okay? You have to test with thought in mind, okay? Now, there are types of tests we talk about. We talk about unit tests, tests of individual functions or classes, okay? And I'm not saying that that's just one test. It's not one unit, meaning it's a single test. I mean, it's a test of a unit, meaning that unit could be a function, that unit could be a JavaScript class that has an, okay? Integration tests. Tests when we pull together multiple pieces, okay, to see if they all want to work together, okay? That's getting more complicated. UI testing. Even harder to automate, okay? So testing the user interface, okay? Frequently, what we mean is a graphical user interface. We're not going to cover that. We're going to cover the first two here. Okay, so why automate the testing, okay? Sometimes you have to have elaborate setup procedures, okay, maybe required before testing some part of code functionality. We want to make tests easy to repeat, okay? Some of these setup procedures can take even a while to set up in the test framework, okay? However, we want to make repeating tests easy, okay? We may have a large number of tests that are needed to be run to ensure the system is functioning correctly, okay? Okay. We may want to report the results of the tests in a nice manner every time we run them. Big software projects will run a suite of tests every time they build. They do a system build, okay? And the build will be considered broken if certain tests fail. Maybe not every test failing, but important tests. There may be tests of different levels of severity, okay? So we want to be able to report the tests and things like that, okay? We want to make sure it's working correctly, and we change something, we're going to rerun all the tests frequently and often, okay? What's our example? Our example is going to be web server development. Even a fairly simple web server API requires initialization of certain databases for a test run, running a server at a particular IP and port, creating a test script to make HTTP requests for each interface and features on that interface, configuring and running a test script to make calls to the server on correct. Wow. Noting the results, debugging issues, and repeating. Okay. So we're going to aim this at web server development, particularly APIs on a web server. Okay. Not a template-driven server, but a JSON data-driven server. Okay. So what's our outline? We're going to go through and review some things on the software development process. We're going to learn about assertions and assertion libraries. Okay. We're going to look at one of the two most popular test frameworks. There are others. I'm not slamming any of them. We're just going to use Mocha as an example. They're all good out there. I've got example zips, one strictly on Mocha testing. The other is a full example with a JSON API with sessions and login, where we've started applying some of these test techniques to test login, test some other things, okay? Now, software process and testing. Maybe you've taken a software engineering class, okay? Maybe you haven't. So, I'm going to be simplistic about this because there's a lot about software development processes and a lot of cool names, pair programming, extreme program, blah, 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 blah. Okay? What's the essence of it? Figuring out the minimum viable project, okay, to build, okay? You got to figure out what it is you're doing, okay? Which means requirements and everything, okay? Identify and attack the riskiest parts of the project early. Unknowns count as risks, okay? So this is key. How can you make the project as small as possible? What's the smallest thing you can deliver and be useful, okay? That's hard to figure out, okay? Because everybody can figure out something that does everything in the world and say, hey, wouldn't this be nice if we had this all singing, all dancing, does everything? That's not the hard part. Figuring out the minimum viable project, product. Sometimes they use the P for project, sometimes for product. That will deliver something of value, whether to you personally or as a company building something. Then, when you've done that, you start identifying the risks. What don't you know about? What don't you know how to do? Okay? And you start attacking those parts early. Okay? How do you do that? You show incremental functionality. Okay? You get some pieces of the project to work. Okay? You make iterations. Okay? That means you take a short period of time, multiple weeks, not months, not years, to come up with some functionality. Okay? That means you may need to mock out part of your design and things like that. You identify those risky parts first, get some incremental functionality, go back and evaluate things, okay, and figure out what the next riskiest part is. Figure out if you modify what the project is a lot based on what you've done. Okay, so we do these iterations. Better to do these in a couple weeks. Okay, usually 2 weeks is nice. Okay, going too long to show some kind of progress is bad because it means you may have bitten off too big a part. Okay, you haven't identified the risks in the smallest piece, or you're wrestling with something that you know is risky, is significant, and you'll break that down into smaller pieces to try and get some progress. Okay? But trying to say, I'm going to do this whole thing, give yourself a month and 6 months to deliver it and not have any signs of progress along the way doesn't work. Okay. Now, how does testing get involved with this? Okay. How do we know we're making progress? Okay, first of all, tests should be linked to requirements in some way. Otherwise, they are unnecessary. Okay, we're not testing for the fun of it. We're testing to make sure our software works. What's the software supposed to do? Okay, well, it's supposed to meet some requirements to do something. Okay, tests can be seen as direct realization of detailed requirements. People don't hand you a set of detailed requirements. Okay, you've got to usually figure out from that minimum viable project or product, okay, what your requirements are. The most detailed requirements are going to be the things that you can test against, okay? Writing tests and having them run successfully is one sign of progress on a software project. Hey, I got this interface working. our server on this API, we ran all these tests against it, and it works. That is solid progress. One sign. Not enough, you know. Okay, it's not all right. Nothing's a cure-all. Okay, because remember, why are we going over these things? Okay, most software projects fail. That's the truth. Okay, and by fail, that I'm not saying it's not ever going to work, but they're way late. They don't deliver on all the functionality promised. That's why we got to pick that minimum viable project, identify the risks, and attack them early. Okay, find out what we're really in for. Okay, because that'll tell us we way underestimated, right? What seems so easy in the abstract, oh, make a UI user interface like this and that. You know, I see this all the time when I use my Gmail. Why can't you do something? That took a lot of developers. That's why. What seems very simple to somebody because they've seen it done before does not mean it's simple to do. Okay? Or modifying that idea over to your situation. Okay? So that's why we're doing this. Okay. Now, software processes. People like to debate these things. What are they, though? A software development process, and I like this definition from Wikipedia, is the process of dividing software development work into distinct phases to improve design, product management, and project management. Okay? So what is product management versus project management? Product management is figuring out what the thing is supposed to do, what features to have in it, and when. Okay? Project management is getting the thing done. Okay? Improving the design, making sure things work, that's robust. Okay? So we got to divide work into chunks. You have to divide it amongst developers. You got to divide it over time. Hard thing to do, especially if you've never built, if no one's ever built something like this before. Okay? So people come up with processes, okay? Rules that you follow to help you organize your work, okay? There are many flavors of software development process, okay? They have different names and like that, and they have their own terminology and stuff like that. If it doesn't include that iterative, incremental approach, like I said before, that's so important, you got problems, okay? If they're all about being totally formal, okay, without showing any progress quick, I mean, relatively quick, that's an issue with de-risking, okay? Now, sometimes you need a lot of formality, okay? Because you're preparing something that's mission critical in some way or the other, okay? So the amount of formality that you need in documentation that goes as you're going, okay, can depend on the type of thing. All these different processes include testing. Some emphasize testing and build around testing. There's two, one's known as test-driven development, as you might guess, and another's, okay, so that's involved with testing, and also one called behavior-driven development is oriented, okay, around testing. Both these have influenced the design of test frameworks, okay? We don't need to know too much about them, okay, to use frameworks such as Mocha or Jest, but we're going to see some of their terminology, okay? So don't panic. You don't have to go become an expert in these software development processes, okay? We're just going to see a bit of their terminology, okay? Now, what else about tests? Requirements and tests are closely linked, okay? So looking at the tests for a project could fill in gaps in documentation. Really, Professor? Really, really? Because there may not be specific documentation about something you're trying to do, but they may have tested it. So you may find a project that has lots and tons of tests, but maybe not detailed examples. Guess where you can get the detailed examples from? Yeah, the tests. Ooh. Okay, that's what part 2 here. Test be a good source of simple usage examples when the document is lacking. Pretty much all but the smallest projects should include tests. You can use them as a partial indicator of project quality. Okay, okay. GUIs are particularly graphical user interfaces are hard to test. Okay, but stuff underneath, okay, the rest of it usually should have lots of tests, or a fair relative amount. Okay, now this whole software process thing, we're going to use some techniques. One, which is called assertions. Okay, it's a formal technique. Okay, it's computer programming. An assertion is a statement that a predicate. Oh my gosh, this is one of those things. Boolean valued function, i.e., a true false, is always true at a point in code execution. Okay. It can help a programmer read the code, help a compiler compile it, or help a program detect its own defects. Oh. Why? Okay. What do we mean by this? An assertion is a statement, oh, at a certain point in our code, we make a little test. A true-false test. If it's true, everything's great. If it's false, things aren't good. Oh. That makes sense. Why did they have to use such complicated language? Don't worry about it. Where are these things used? Okay. In some software design methodologies, such as design by contract, or test-driven development, or behavior-driven development. Okay. Another place is in development or runtime correctness checks. Okay. Sometimes we'll throw in a lot of these things called assertions in during development, and the compiler will remove them, depending on the type of system we're using, come runtime. Or we'll leave them in for runtime correctness checks. Okay? In software testing systems such as Mocha or Jest, we're going to use them to make tests easier to write and understand. You're going to see that in a second. Okay? We're not going to have to redo every check and way of checking things. These assertion libraries are going to help us check lots of stuff. Okay, are these exceptions? Well, in JavaScript, the assertion libraries generally use JavaScript exception mechanisms, such as throw and try and catch. Okay, and many build off the standard error module. Okay, error object, what's that? Oh, error objects, we don't need to take that survey now. Error objects are thrown when runtime errors occur. Oh, error object can use a base for user-defined exceptions. See below for standard built-in error types. Oh, gotcha. There isn't a standard assertion interface for the browser. Node.js, though, has an assert module. Oh, okay, so people really use this stuff. Okay, they use them in many languages, other languages too. Okay, it's not just a JavaScript thing. Use them in C, C++, and such like that. Okay, now we're going to use a particular assertion library. Why? Because I like it, and it's very popular. Chai is a behavior-driven development, test-driven development assertion library for Node and the browser that can be delightfully paired with any JavaScript testing framework. Okay, my take, it makes writing test cases just a ton easier. Okay, so what do these things look like? Okay, so here, this is on the Node side. We have assert equals require. Oh, we're bringing in Chai and the assert portion of its library. We'll see that Chai has a couple different forms, okay, but they have all the same tests in both forms. Okay, now I've got a variable here, okay, and I've got an object here which has a sub-object, that has a sub-piece which is an array. Okay, what kind of things might I ask? Assert, type of foo, string. Oh, So I'm going to assert that this variable, the value in it, is a string. Okay, that's okay. We can have an optional message, okay, that comes out, especially if it fails. Suit food is equal. Oh, well, we got equality operators. Oh, length of. Oh, well, that's a little bit newer, a little bit more modern. Okay. Oh, length of beverages.t. These are kind of unusual. I don't have to sit there and go pull out the length attribute and stuff like that. That's getting a little helpful. Okay. What good is this? If the condition of the assertion is true, nothing happens. If the condition is false, an exception will be thrown with useful info. Chai provides a ton of different kinds of checks. See Chai assert. Chai, we go look at their API documentation, and I'm going to be using the assertion style rather than the expect should style. Okay, we come down here, and is okay, is not okay, equal, not equal, straight equal, is not deep equal, is above, is below, is at least, is true, is not true, is not nan, is defined, is not object, is it an array? Oh, just tons of tests, 120 different tests. We don't have include. Okay, include haystack needle, parameter, an array or a string, okay, and we ask, asserts that the one thing includes the other, okay, the inclusion of a value in an array, a substring, and a string. Oh, wow. Well, that's nice. So it makes writing these tests easier, okay. They got a lot of simple checks they'll do for us. We don't have to do them all ourselves. Now, they have another style of assertions, okay? And these are expect style assertions, okay? They look more like English. Expect blah to be a string, okay? It reads like English. I'm used to the other style assertions, the assert style assertions, so I don't use these, okay? So I won't be showing you them in the following examples. That doesn't mean there's anything wrong with them, okay? I am not a testing expert. I just know it's useful, okay? Now, so that's one piece. We got to make these tests. Now, what's the test framework do for us? It seems like the assertion library, Chai, does a lot of the work for us. Okay, what do we need beyond assertions? A way of running multiple tests. Okay, this is known as a test runner. A way to set up and clean up after tests or groups of tests. Okay, mechanisms for grouping together, tests together, and describing them, making this thing be self-documenting. Okay, the example test framework we're going to feature in class is Mocha. Okay, also important for us is Mocha supports testing asynchronous code. I think all the other babies do too. Okay, it's a full-featured. Okay, here's the thing. Mocha is a very fully featured testing framework and can appear overwhelming. It's not, okay? It's not. It really is, okay? I recommend this quick and complete guide to Mocha testing, okay? We're going to see once we get into it, it's just the initial documentation is kind of terse because people are used to the frameworks and this kind of stuff, and so it's like, what is this stuff? Don't worry, we're going to see, okay? We only need to use the full of the functions and features, okay? And we got this testing zip to get you started. Okay, now, Mocha is a testing framework, okay? You can do a global install so you can use it in all your projects, okay? That'll also let you issue the command Mocha to start the test from the console, okay? You can also do a local install and use the appropriate path down to the executable as need be, okay? but I do the global install for Mocha. Assertions have to be local. I discovered that. Okay. So test runner usage, basic usage. You say Mocha spec, where spec is one or more files, directories, or globs, files with partial names with star whatever's in them or dots or whatever to test. Okay, and this will give you like directories or globs to tests. Okay, this defaults to the test directory. So you'll see in my examples, okay, here's my Mocha testing thing. There's not much in here. Oh, there's the test subdirectory. That's where I have all my tests. Okay, that's where we're going to watch those tests run. Ah, gotcha. Okay. You can put a script in your package JSON that says scripts, test, use Mocha. Okay, got it. Okay, we're going to just use the simple command line. See how that works. Okay, but there's more. Okay, so Mocha group testing, test grouping by directory. Default looks for the test directory. Separate files for different groups of tests. There's a describe function for grouping and documenting similar tests within a file. The it function, oh, yeah, for a while there I was going, what's it? What's it? Why? This is like as bad as the is in JavaScript. No, it stands for individual tests. So we'll write we'll use this function for an individual test. We can test multiple things in an individual function. Okay. But that's up to us how much. Okay. So let's take a look. Okay. From getting started, and I also put this in test.js. So let's take a look. Mocha testing. Open with brackets. Now we're going to go into test. Okay, so within test, what is this? Var assert, require assert. So I'm not using chai yet. Okay, I'm using the built-in stuff from Node.js. Describe. This is an array. I'm going to test an array. Okay, describe index of. I guess I'm going to test the index of function of the array. So describe function. Oh, all this stuff is arranged like a bunch of callbacks. Describe takes a first value, then the next thing it takes is a callback function. Then this is within that we can do another grouping. Oh, you think we needed to get used to callback functions this semester? Yeah, fix another one. And finally we get down to this. Professor? Yeah. Where do we run this? We don't. Mocha will. Okay, this is the format that Mocha expects. Let's see this individual test. Should return -1 when the value is not present. Assert equals. Here's an array, 1, 2, 3. We ask for the index of 4. What's it supposed to do? Well, go read the documentation, but it's supposed to read -1. Why do I know? Because it says so here. Okay, how do we run this test? I may get this wrong because it has a confusing name. So if I go Mocha test/test. Why am I going test/test? Because everything's in the test directory and I happen to give this file the name test. Okay, that's why. Okay. Because if I just said test, it would run everything in the test directory. Oh, it'll do that? Yeah, it'll do that. I told you, this stuff is made for running lots of tests. Okay, so what did it do? Let's look at the output closer, right next to this. Okay, assert, okay. Array, that's the first grouping. Oh, it prints that out as documentation. That's the first level of grouping. Then we're running a test on index of. Oh, this is the second level grouping. Why do they do all this? Because people need to write a ton of tests. Yeah, you got it. Now, down here, we see the output of a particular test. Okay? Should return -1 when the thing's not present. Can we fail it? Yeah, of course we can fail it. Let's fail it. See what it does. Okay, assert. Let's put a 4 in there. Let's make our test faulty, not the array method. Okay, so our test is kind of incorrect. Remember, that can be as much of a problem as your code being incorrect. Okay, let's run it. Splat. Okay. 0 passing, 1 failing. Array index of should return -1. The value is not present. Assertion error. Assertion 3 equals minus. Expected, not actual. Oh, yeah, this didn't work. Yeah, because it's in there, so it returned the thing. And it knew the value of it. Okay, let's put it back. Okay, that was the dog barking in the background. We got friends here. Okay, test should return -1. So we're back to working. Got it. Okay, what else do we have? Important parts. Tests are JavaScript code. Assertions of some type need to be used. We don't import or require Mocha. We run the test files with the Mocha and not Node.js. Mocha is going to run them. It knows about that format we just saw, that grouping. Okay, so we saw the example output. Okay, let's use some chai assertions. Okay, we're going to do the same thing over again. Okay, but this time we're going to use some chai assertions and run more tests. Okay, so let's take a look. Let's look at the code. Looking at the code, test with chai. Okay, so now we're requiring the chai assertions, and we're requiring different types. Okay, now we've got an array. Okay, it's an array. Okay, so we started off with an array. Now I'm saying, let's assert that it's an array. Okay, let's assert that the array contains 2. Okay, assert here is array. Include numbers includes 2. Array contains 5 numbers. Length of numbers. Oh, I see. Got it. Okay. Describe. Oh, here's the other forms of writing up those things. Oh boy. We got problems? The doggy is unhappy with my teaching. Okay, let's try running this. Okay. The doggy really doesn't like my teaching. Okay. That's okay. It's not the first time. Test. Oh, yes, test. Chai. Okay. Here we go. Oh, so it goes and checks all these things. Okay. So we get documentation that we just passed those tests. Okay. Great. Cool. Wonderful. Example output. Okay. What if we need to set up things before and after the test and clean up after the test? Use before, okay, and after to clean up things after an entire group of tests, okay? Use before each to set up things before each test and clean up things after each test, okay? Before each one of those individual tests, okay, or groupings, okay? So this is what that code would look like, okay? Describe, before, after. This runs before all the tests in this block. This runs after all the tests in this block, okay? Before each runs before each test in this block, okay? So we can do these things in blocks, okay? You write a ton of tests, okay, as you build up more and more functionality in your APIs and your server interfaces, okay? Let's look at testing a function, okay? So what I had, okay, requirements drive the tests. What I had is an algorithm for doing peer review, okay? A set of N students have submitted homework assignments. we want each student to review M other assignments, okay? So they have to review M other students' assignments, okay? Might just be one, usually more than one, so we can throw out really bad reviews, okay, and such like that in case people have issues, okay? So usually ask them to review more than one assignment, okay? But they can't review their own, okay? A reviewer cannot review another student's paper more than once, okay? We must make sure that each student assignment gets M reviews. Ooh, that's kind of a tricky set of requirements. Ah, so I've got some algorithm code here. Review assignments, okay. I give it a number of students. I give it the number of things to be reviewed. I ask it, okay, do I want it randomized? What it's going to return to me is a list. For each student, okay, a student is going to review or have a set of reviewers, so many reviewers, okay? That student then will also have to review so many other papers, okay? Wow, this looks confusing, Professor. How can we tell if it works? Good question. We're going to write some tests, okay? Describe peer algorithm tests, okay? So I'm going to bring in my peer algorithm, my peer review algorithm, okay? I'm going to say, set some variables. Number of students, I'm going to have 15 students in this class. Each student, I'm going to ask to do 5 reviews. Okay, I want things randomized, okay? And I'm going to bring back assignments and reviews, okay? This thing returns 2 arrays, okay? Who's reviewing what, and who did you review, okay? First thing I'm going to do is figure out array and set checks, okay? Length, reviews, and assignments. Checking if I get back arrays for both these things. Checking the length of these things. Do they correspond to the proper things? Number of students, etc. Now, reviews and reviewees, I go through and I'm going to check that each student must, oh, this reads like the requirements. Okay. Cannot review yourself checks. Reviewer cannot review themselves. Assignment cannot be reviewed by author. Reviewer cannot review themselves. Double checks on each way. Bad input checks. Oh, so if you give the algorithm bad inputs, this is when you're making a general piece of software that other people use, you should do something when they give it bad inputs, okay? Number of reviews is greater than the number of students. Gotcha. So we make a bunch of tests like that. Let's go take a look at it. Okay. Peer review tests, okay? We've got all these things here, okay? Complicated algorithm doing complicated things, and we want to make sure it meets all the requirements. You don't need to study the algorithm. You don't need to study all the tests here, except see that these things sound like the requirements for the algorithm to produce these things, okay? Sets of stuff that we can then use to assign students to review other students' works and such. Okay, I got some extra documentation at the bottom there. What am I going to do? I'm going to come over here and go Mocha. Peer, oops, not the algorithm, it's down in the test directory. Test, peer, rev, tests. Okay, it runs each one of those checks. Now, if this was a real project, I would have all my tests down in this test directory. I just click Mocha, and it goes and runs every test file I have in there. Okay, that makes sense. Okay, because a lot of times we want to rerun all the tests. Okay, it's something we do frequently. Okay, to test that we didn't break something. Okay, get this nice output. Okay. What about asynchronous things, Professor? We're talking about websites. Oh, yeah. APIs, calls over the net. Okay. So, Mocha has support for asynchronous testing. This can be done callback style. be it done. Yeah, we learned about promises. We can use promises, okay? But even more so, what I like to use is async and await, because most of my tests, I gotta want things done in a particular order, easier to think about and stuff like that. If you need to get really tricky with things going on in parallel, you can go with promises, but async and await, easy peasy for me to think about. Okay, so here's my server. Okay, it's a tour company. Okay, my Galactic Wind Tour company. Okay, and it's got a bunch of different interfaces. Tours, get. Okay, and I haven't finished it yet. Should do a lot more than this. Tours, get. It's a get interface. It's going to return an array of tour objects, each having name, date, and type fields. Okay. And it also sets a cookie. Okay. Login, post. Okay. It takes an object with email and password. If successful, updates the session ID and cookie. Oh, we're going to make sure our session management's working. Log out. Get and session removes cookie. Okay. So client server and debugging. Okay, look at this is in the previous session JSON example. There's a test directory. We didn't look at that before. Okay, so let's see how we're going to test the getting tours interface. Okay, assert. Assert, require try. I'm going to use the assert style. Fetch, we're going to use node fetch to make the calls. Get cookies is a little program, little routine I ran just to get the cookies. Okay, that works. It knows how to get the cookies out of node fetch and just put them in a format so we can send them back. Okay, not trying to do anything too fancy with the cookies. We just know that we need to send back cookies, that we receive what set cookie as part of our response. URL base, little trick I do to pull where I want, because I can use the same stuff to check on my deployments. So I put the URL in a separate file, so I only have to update it in one place. Okay, so get tour tests. Okay, describe. Before I get started, I'm going to do a fetch. I'm going to fetch the tours. Okay, and put that into the response. Okay. So fetch with await, I'm going to get back the response. Okay, that's what I'm going to do before I start all this group of tests. Okay, first test I'm going to check. What's the res status? The status of the response. Okay, what did I get back? I'm hoping I better get back 200. Okay, now, that's right. Response, I need to get back the information. I know I'm getting back JSON, response.json. I will wait for it, put that into tours. I assert is tours an array. Oh, this is not so bad. All tour elements have a name and date. Now remember, I pulled out tours here. Now I go tours for each, assert. Look at this. Contains all keys. I'm saying that this element of the array has two things in it at least, name and date. Oh, checking that we're getting back the right information. Ooh. Cookie with appropriate name is returned. Woohoo! Let's go do this. Let's do this. Okay, so I'm going to turn this one off. Now let's go over here. We're going to go back to our server. Server, express sessions. Sessions JSON example. Okay, let's bring up a thing. Get bash here. Okay, we got get bash here. Okay, let's just try it. Mocha, just Mocha. Calling test, calling fetch. It crashed. Oh. Error, timeout of 2,000 milliseconds exceeded. Oh, I forgot to start the server. Oh, I guess I need another window. Okay, new. Now this one, let's see, I think I separated my start server run into a separate file. Node server run. Okay, server's running. Okay, now let's just try that one test. Okay, these aren't the tests. The tests are in here. Before, when we were learning how to do stuff, we did some tests outside. This is with the test framework. These are the Mocha tests, okay, like you see here. Now, if I want to run an individual test, I say Mocha test tour test, okay. Bling. Get tour test. Everything is okay. All tour elements have a name and date. Tour test cookies. What kind of thing is this? Cookie with the appropriate name is returned. Oh, when I'm debugging stuff. Okay, did I clean this up here? I might have cleaned this up. Cookie with appropriate name. No, I didn't clean this up. Okay, when I'm debugging stuff and debugging my server, okay, I put console log code in here. Okay, when you're running the test runner and things like that, you don't want to necessarily do this, okay? But when you're debugging, it's very nice, okay? Because you do the test, something doesn't run, things fail, that's why you're running tests. I print out debug code. I'll take it out for when the tests are being used over and over and over again because nobody wants to read this stuff being spit out. But it's a good place to run some checks. It's this receiving stuff from the server, okay? I'll put some tests in my server too, right? You know that, right? Over here, see? You can see some tests in the server that I mean debug messages that I'll remove or turn into formal log messages. Okay. So we see a nice way to run all those things. Did we get back? Now, you saw these results. Okay. Dealing with session cookies. I wrote a little bit of code, okay, that I pass the response from node fetch, okay. Other libraries for doing requests may get you back cookies in other ways. Node fetch says, I'm not going to get involved with this. I'm going to give you the set cookie header, okay. Why is that different? You won't get that in the browser. The fetch in the browser does not let you get those cookies, partially because some cookies you're not allowed to see from JavaScript, okay? So this is something they do for running fetch in Node because we need this, okay? We can't log in without the cookies. So what does this do? Takes the response, looks at the headers raw, it's a set of strings, gets the stuff, the strings that have set cookie involved, returns all those, okay? Then, for each raw strings, for each of the raw strings, remember there can be multiple cookies. I'm not using them on my website, but there can be, okay? Many places use multiple cookies. For each, I'm going to run through the cookie in text. I am going to split out, okay, the stuff that's by semicolons. I just want to get the name value part, okay? So, yeah, this is just me hacking a little bit, okay? There are libraries to help you work with cookies. Just didn't want to get into one more library, and wanted to show you that, look, we're just getting the part from set cookie. Okay. Now let's try testing login, okay? Try assertions, node fetch, my little get cookie function that I wrote, okay? URL base, just so I can easily point this to my local testing like you're seeing now, or if I want to test my deployed website, I can use the same test. You can't? Yes, you can. Okay, login tests. Okay, before. Oh, look at this. I forgot to mention that before. We always have to say async here. Why? Because we're using wait in here. But notice, it doesn't mind us doing this, okay? Before took a function. It's okay with an async function. Oh, okay. So we're going to call fetch. Okay. What am I going to do? Call fetch. I'm going to go get the tours initially. What's this going to do? Well, we learned with our session management, it's going to return a cookie. Okay, an initial cookie. Okay, so what am I doing here? I'm running my little function get cookie. Okay, and storing that string of stuff back in my cookie. Okay, why? So we can return it. Okay, now what do I do here? Assert cookie with appropriate name is returned. Okay, assert include. This is kind of like what we saw before. Okay, assert my cookies. Okay, now describe login sequence. Okay, before fetch. Okay, res await. Okay, fetch login. It's a post. The body, email, password. Password in the clear, never this code on a server. This is not code to be put on the server. This is the test runner. This is the test to be run. Okay. Header, content type, application JSON. Okay, because we're using the node fetch interface. Look, that's how easy it is to send back the cookie. Cookie is the name of the header. Okay, we don't have to say content type or anything like that. That had a big fancy word in it because you can't put the minus sign as without putting the quotes around it. Okay, that sets the cookie to send back. Okay, what's the next test? Okay, so we're logging in. Okay, first thing we're looking. Individual test, login good. Assert, we did that post to login, that the status equals 200. Okay. User returned. From this interface, I was going to pass back to the application first name, last name, and role. Okay. So I'm going to check contains all the keys. So whatever I got passed back in JSON contains those keys. Okay. I'm going to check. Okay, because we just had an elevation and privilege that my cookie session ID changed. Okay, so I'm going to assert that the cookie I received back. Okay, this cookie, get cookie res. Okay, I'm going to assert that it came back clean. It's not empty. It came back not empty. It's not equal to the previous cookie I received. Okay, and for debug purposes, I'm going to log it. Okay, now. As important as good logins, it's important to test bad logins, right? We want to make sure our logins aren't broken, okay? Our authentication isn't broken. So here, I have an individual test, bad email. What did I do? I took the good email and added some characters to it, okay? Send it off. Assert, I assert I should get back an error code, a 400 series code. Okay, bad password. Okay, what am I asserting here? What did I do? I took the whole good stuff and I changed the password a bit. Okay, assert here, return status is again an error code. Let's try running that. Okay, so where are we? Session ID, Mocha test / login test. Bloop. Okay, login test. Calling fetch, back from fetch. I was doing some debugging. I had some debugging messages to help me as I was getting this stuff working. Okay, cookie with appropriate name is returned. Login sequence, good login. Login good, that passed. User return passed. Ooh, look. I did a check to see what the previous tour session ID was, and checked that it was different. Cookie session ID changed. Bad logins, I checked the bad email and the bad password. Okay, I can run all these tests at once. I just type in Mocha. Okay, and it tells me how long it took the tests. Great. So we shouldn't have broken interfaces. Okay. Now, testing support in IDEs. It's hard to read this thing. This looks like I was doing, oh, this is PyCharm, I think, or so. Let's take a look at our first set of tests. Okay. So here I am, and let's make this big. I'm using Visual Studio Code. Other IDEs will have support for test runners. Okay. So here is this is my initial set of Mocha Chai tests. Okay, Mocha testing. Okay. So I have my test directory down in here. You can see peer review test. Ooh, look at this. They have like a thing to click on run and debug right in the test. Okay, because there's a thing for test exploration. Oh, I can run an individual test. Oh, I can? Yeah, you can. I can run all the tests. Okay. These little marks indicate they worked. Do you want to break one? Let's break one. Okay, so let's go. I don't know if we can. I don't know if that. I'll have to go look here. Let's see. Test another array text index of should return. Okay, for the one for the index of 2. Let's break this test by inserting another number here temporarily. Okay, then we're going to come back to our test environment. We're going to say run all the tests. Splat. Another test. It's going to show what actually happened. It's going to take you to where the test failed. Yeah. Okay. Then you can start debugging. Sometimes I like debugging here. Other times I like to be able to see the spit out from the test runner. Okay. I'm not a super big user of this test runner, so I'm not used to all its features, but let's put things back. Let's rerun the tests. Is it still broken? Did I forget that? The tests are, another array test. Why is it saying it's still broken? Should return 1 for the index of 2. Did I leave this broken? Nope. Did I say I'm an expert on this? Rerun them all. Okay, everything came through good now. Okay, so that's an example there. Okay. For my server, similar thing. Okay. I have a set of tests. Okay. I can run them all right in my development environment. Okay. Nice. Okay. Like I said, you get to know, if you use a test framework like this within your IDE, you get to know its features so you can see. I mean, I got used to, oh yeah, I can really see all these, and I look at these spit outs, okay, of information of debug. There's a way to do that here, okay, but I'm not quite that familiar with it. So where are we? A lot of IDEs support testing. Testing is wonderful. Testing is really needed for server APIs because when you're trying to glue the front end, your app, to the back end, the server APIs, it really, really helps to know ahead of time that you've tested at least somewhat that server API, because that integration of front end and back end initially is painful. All right, run some tests.